I'm Neil from Robotics Competition News, and I'm here with Team 4513, Circuit Breakers, and with
Nathan.
Lauren.
And Josh.
And walking around the pits, I noticed that you guys had a really cool gear intake system. Would you guys mind talking about that?
So our gear mechanism pretty much can translate from like side to side. So we can say like when we're moving onto the peg, we can like move it side to side, so we don't have to move our whole robot. We can also rotate the gears so that we have like an open spot for the peg to go into every time, and like it will also eject the gear onto the peg, so we don't have to wait for someone to pick it up. And that's pretty much our gear mechanism.
So I know that when teams are doing really precise movements like this, they have difficulty lining it up manually. So how do you guys get around this?
So we have an vision processing system that we use especially during autonomous. So we have a camera with a green LED ring that can reflect off the reflected tape, and then we can use vision processing with the RoboRia and RoboRealm and actually find the center of gravity, and then use trigonometric functions to figure out our distance from the target and how far off we are. Then we use a gyro to set it to a certain heading that is the angle of the target off of our gear, and then just drive straight on, and then eject.
So when this vision processing takes over, is it all completely autonomous, or do you guys have any intervention when you're working on the robot?
Well, when we start autonomous, it's pretty obvious it's autonomous, but sometimes during teleop, we just can't seem to line up the gear, so we can press a button and we have a command that will do our autonomous routine for us, and it'll place the gear, and it's been pretty useful. It has a little bit higher average time putting the gear on because our pilots have been really good at putting the gear on themselves, but it's been very helpful in very, very many circumstances.
How long does it take for you guys to line up to the gear and for the gear to actually get onto a rotor?
For vision, when we use the vision program, it takes around 5 to 6 seconds, and doing it manually can take anywhere from 3, and if we have bad lineup, maybe up to around 10, but usually between there, so it's pretty good time.
And what motors do you guys use to actuate the gear mechanism?
That'd be Nathan's.
We use 2 window motors, one for our ejecting mechanism and a second one for, I believe, rotating the gear. And then we use a Andy Mark motor, I don't remember what number it was, but we use that motor to translate from side to side.
Well, this has been very interesting. Thank you guys very much.